Welcome everyone to the sixth webinar of 2025 of the IVRPA series. My name is Scott Whitty. I have the honor of serving as IVRPA's president, along with an exceptional dedicated board of directors, including one, Lauren Imbrando, who is our presenter today. IVRPA, the International VR Professionals Association, is the only international association dedicated to helping our members and the wider VR XR community of creators be more successful. These webinars present content usually that you can't find elsewhere. In this case, you can find a lot of it, but the approach will be a little bit different here. Today's webinar is strictly an introduction to Gaussian Splats. Future webinars, one or two, will go into more detail of how you actually produce them in a real life situation and produce saleable content. This webinar is being recorded and will be available to paid members on the IVRPA website, along with all past and future webinars. If you aren't currently a member, I encourage you to join. For the minimal cost that it is, you get an awful lot of value. There will be a Q&A session at the end. You can ask questions and bring in your own observations. Many of you may have lots of experience with this, and we really want to hear from you. When you, in the Q&A, when you are writing something in that text at the bottom of the Q&A window, the blue text above it, make sure that you have clicked send to everybody, or else only the panelists, the board members and presenters will see it. If you want everyone to see it, be sure to click everybody in that section. And with that, I guess we'll turn it over to our star. Lauren, take it away.
All right, thank you, Scott. And good morning, everybody. I'm Lauren Ibarrando. Today we're doing a webinar on Gaussian splatting. More of an introduction to it. I have the and XR, but we're going to get more into the XR part of it in a second. What we're going to cover today is really a foundation. I'm not going to get into the heavy mathematics of it, but I want to show you what is the traditional graphics pipeline, that we sit in right now, how this new technology fits within that. It's not a replacement to it, it's an augmentation of it. It's very new. We're not really sure where it will end up. But it does have its roots, and I think that's a good way to understand it, is to start with the foundations that we have. So we'll talk a little bit about classical ray tracing, even though that's not how we produce most images nowadays. We use rasterization, but it'll give you the concept of how light is passed into a scene and reflected back, and you'll understand how we build geometry from this. I'll show you kind of an adjacent workflow. You're familiar with the underlying algorithms or the techniques for feature detection between images and how we get control points. That same approach you'll find in this structure for motion, and I'll explain what that is. Then we'll start to get finally into the Gaussian splatting, what it is, and then I'll show how we're really taking the point clouds that you're familiar with in photogrammetry and LiDAR type scanning, and how we're swapping those points out for, I guess, smarter type of thing. And then we'll get into the actual examples of it itself. So the traditional 3D graphics pipeline that we've been using for quite some time is very complex. We're all familiar with the whole world of modeling, texturing. If you look at movies, you'll see entire teams that are doing just shading and all these types of things. They're very complex calculations. We have multiple stages where we'll render an image out, and then the lighting part of it, and then the shading on top of that. And one of the aspects of this that's important, or really kind of to understand the deviation that we're doing now with the Gaussian, is that this entire workflow requires a really pixel perfect accuracy. If we have a model where a seam is opened or it's got a hole in it, or we go to render something, those discontinuities that we end up with because we're trying to get a single pixel, they really pop out at us. It's a very unforgiving environment to work in. We've also, until recently, been been unable to achieve real-time rendering with all of the lighting effects and the rest of that. But the advent of the RTX boards and the kind of the progression where the GPU is splitting off from the CPU, and now the ray tracing and other types of math that is fundamental to this is found on the GPU as libraries. That's a pretty important part of this. And if you get into this and you're starting to work with training the models yourself, you're going to want to have some pretty heavy hardware, and that is a critical piece of it because those libraries will be required for the ray tracing to achieve it in real time. But the difference is quite profound, though, where with the traditional graphics pipeline, we've only recently been able to achieve real-time rendering, or 30 frames a second or more, with the visual perception of motion, to where in the Gaussian, they're actually easily having 120, and in some cases, they're getting upwards of 1,000 frames a second, which is pretty exciting because it brings about a world where we're not rendering things, we're moving through them immersively in real time. So that is very, very powerful. This graphics pipeline is very powerful, but again, it's intensive and it's inflexible. Also inflexible to the creator. This is not something that really any one person can be, an expert at. So that's why you end up with teams, which tends to dilute the creative process. So now just to cover really quickly what would be considered classical ray tracing. And throughout this, oh, and I'll put the PDF here when we get to the end, so you can click on the links. Throughout this, you'll see if in the upper right here, this image is from a very famous paper. There's a lot of papers and GitHub stuff in here. Some of them are very technical, but with PTGUI, with ChatGPT, I would go ahead and take those papers and hand it to it and as a PDF and have it explain it to you if you're interested. But the fundamental concept here is that in ray tracing, we're trying to replicate what we have in reality, where there's a light source or light around and it all bounces around and then reaches into our eye, the back of our retina, and produces an image. In classical ray tracing, we reverse that process and we shoot rays out of the camera into the scene. It has geometry that we've built, scanned in, photogrammetry, whatever. And that light is bounced around the scene in reverse to see which ones hit the light source, which ones hit shadow, and that is now created onto a 2D plane or an image. So that's how we cast light out into the scene. And so that's ray tracing. The structure for motion, which we're going to be using in reverse to take, I'm sure you've heard that this process of Gaussian splatting requires either a video or a series of frames of a space or an object. Those are referred to as source images. Sometimes you'll hear them called ground truths, but they're the photograph of the scene. And we're going to take those images, load them in, and then reverse out of that the motion of the camera or its position. And before I show you what structure for motion is, just so you don't think that it's exotic, you've been using these same types of techniques whenever you stitch an image. And here we have, very familiar PT-GUI, and I just have a screenshot from it. And I want to just zoom in. I've taken, when you click on a control point, it'll show you a little bit closer view. And I've just picked two of the control points. I'm sure you've seen that it picks features, items in there. Note how in this case, it's picking up the edge, but it's not picking up the exact edge. It's moving a little bit off of it. That's because the algorithms know that as you move around this 3D object, that sharp shadow edge is going to move. And so it would be what's called invariant to scaling or to motion or movement. And so these algorithms account for that, and PT-GUI and others, they started with SIF, but they now have their own proprietary and they've learned a lot. And that's why when you stitch images in PT-GUI, you'll see that the stitch line will go through opaque areas. It'll avoid text, things like that. That's all of the same type of an algorithm where you're detecting, features out of a flat 2D image. So how does the structure for motion? And now the motion is from this. It means that you move around this object that you're trying to photograph with a camera or video. And so that's the motion part of it. Let's suppose we've got this artifact, right, this monkey head, and we take these pictures around it from various angles. And I'll show you here in the next slide the very specific process or approach that you'll need to take for how you do these. It's very different from how we do it in virtual reality. But as you move around, let's pick out these detection algorithms. They're able to find features, oversimplifying it, but the eyes and the mouth, it would be able to find that. And as you move around the object, those features that it detects, both their size and then the relationship between those starts to change because of the parallax. That is how that reveals the hidden depth and structure, and you're able to build that 3D geometry by understanding how you move around. For the Gaussian, we're going to want to understand those camera positions. That's what we're extracting out of this. In photogrammetry, we would have taken and created a point cloud and then turned it into a mesh, but we're doing something a little bit different here. And the reason is that with an AI, we're able to create, or I guess it's called a novel view, but between known images, if there's not too much of a movement between them, we're going to be able to determine what the geometry would have been at that position, even though we don't have a camera position from that. And that's called the novel view. So this is what the structure for motion is. But again, most of the software you're going to use, most of the methods this is all automated for you. Unlike PT where you go in and you'll pull up a control table or you'll move points. This is this you don't really get into. So don't worry about it. I think it's just important to understand what the term structure for motion is. You'll hear it a lot, or what the underlying, because it will affect, or you'll have mistakes or you'll have issues as you get into it. So now starting to get into the fundamentals, or how do you do this? I'll show you the software tools and where to download stuff. But the real thing now where you have to pay attention, you're going to have to, I would recommend just getting your phone. Don't mess with a camera or DSLR. There's more complexity to that. Yes, you can get better quality, and I wouldn't mess with a video or 360 videos yet because they add complexity to it. I would start with, and I'll show you the tools, because you're going to want to practice. The first times I went out, I was making mistakes, and because it's so different. And so unlike in virtual reality photography, where we're using a panoramic head or a tripod and we're spinning around a nodal point, we're trying to get rid of that parallax. In this case, you don't want to rotate. You want to pan and move around. Again, at the bottom here, you'll see a link from Autodesk. There's also in the resources another link that I have, because this is when you go to look for tips and tutorials on how to scan spaces and objects, don't look under Gaussian splatting, look under photogrammetry, because that's been around for a long time. And I've given you two excellent resources, one from Autodesk, and I forget who the other one is, but it covers if you're doing an object, outside versus inside, if you're doing a mountain, a building, if you're using a drone, cameras are all slightly different. Fundamentals are you want to approach it like you're peeling an onion. That's been described in some of the YouTube videos that I'll provide to you. Is if the object is, think of an object now, you want to go around it, get the whole thing. You want most of it in the frame. You want a lot of overlap between the images, right? Because just like you do in PT that algorithm needs a lot of overlap to detect. Hold off on the high quality gear right now. There's a lot of, you'll want to learn the basic technique first. Focus and aperture, again, it's pretty similar to what you want as much in focus as you want everything in focus. I'll show you what happens when you don't. Plan it out as well, the capture path, especially when you start to take, I had problems when I do series of steps and I'm trying, some of the apps will have an AR guide that'll show you as you're building it, like a Matterport does. Some of them don't. And if you haven't written it down in your head and you're going to start taking 300-400 shots, and you can see like the picture I have here of the room, that's showing it like it may be at mid-level, but you do one also towards the top, maybe pointing up a little bit. So you're going to end up with these multiple passes around the room or multiple passes around an object. And I found that I would lose track of what I had taken. And I'm seeing that I got to have a much better plan and approach and, marking down the shots that I've taken, or, hopefully the software would have that AR thing so you know where you're missing it. I guess what I'm saying is when you're out shooting a real estate shot and you're on a tripod head on a panorama and you're spinning things around, if you don't watch yourself, you can miss a shot or forget to take the up or down or something, and you can get past that or whatever. In this case, if you miss something or you have problems, you can't recover from it. They had in here a lot of ones that said for, the reflection and would mess things up, and I found that to be true, and they were saying use matte spray, but I'm not really sure about that. So I'm putting down these as tips and stuff. I haven't tried all of these. But somebody should go to a museum with some matte spray and spray it on stuff and see how it works. Just kidding. Don't do that. Uh, Take a lot of imagery, but the images have to be good. And you do have to cull the images. I've had problems where I'll take 300-400 shots. Again, using a DSLR, which is it's not as automated as a phone, one or two blurry images will blow the experience. And like I said, pan instead of rotating. You don't want to rotate. So when you've done this, and this is an example from a screenshot from one of the program's reality scan, and you're seeing there is this resulting point cloud, and the camera, it's showing you the camera positions around it, and the that's the beginning point of the Gaussian splat. We're now going to deviate from the standard process into something new. And it's really quite fun to, really quite simple, is that rather than tracking these individual points, and at this point with the point cloud, we would now we want to turn it into a mesh. So we'd be cleaning it up. The points would get converted into triangular meshes, or, you know, surfaces with NURB surfaces or things like that. And the textures would be to be baked into it, things like that. But each of these points in the cloud um, is only handling its position, its colors and stuff. There's not a lot of information there. And so what we do is we replace it with in this case, it's an ellipsoid, but we're not going to get stung up on or hung up on the shape because they've already changed. But the real power here is that we're carrying a lot more information instead of in a point cloud or pixels that we would work with. We have 16 parameters that we're working with: the position and the shape and orientation of this. And this is a Gaussian ellipsoid. So we take these balls or points and we convert them into this volumetric ellipsoid that we can control the density of it, its opacity, its color, its orientation in space. We can stretch it. So it ends up being a lot more useful at an object. But what we're going to do is, instead of building a mesh, we're going to smear these things out, split them, kind of use them. I like to think of it as maybe like nanobytes or Legos, in a way, like visual Legos. And we're going to combine these using an AI engine and the photos that we've taken. So we're going to load up one of those photos of the monkey head, and then we're going to convert it. We know where the camera's at, we know where that head's at, and we can move around it, and we're going to convert that head into one of these shapes, and we're going to compare that against the image with an AI, and the AI is going to say, well, wait a second, it's not close enough, and it will be able to adjust any of these 16 parameters, its color, it's a thing in space. It'll move it, and it'll be able to split it. Like if it needs to make something, maybe it's trying to make a joint, like where an arm goes to your elbow, right? And it's going to start to fill these in, and then it's going to retain from the photos that view dependent characteristic, which is very important, because if you're looking at water and a reflection of water and you start to move, that water will change from blue to black to, to pure white, right, as the reflection goes across it. And up until now, we haven't been able to capture that in our scanning. We just end up with a piece of geometry that we then have to go in and light and apply reflections and do all the calculations. In this case, we're just capturing the information, and we have this ellipsoid which has enough data in it that we can capture that. So that's one of the more fascinating things of these Gaussian splats, is that you'll see it here when we get to it in a second, that as you move them, you're seeing that the radiance fields, or all that kind of stuff. The other very important part of this is that because we're just tracking these ellipsoids, they're these 16 parameters. We're not trying to calculate the ray tracing. It's pretty simple linear algebra, just moving matrices around, and we're able to render that in real time. Now, there's two parts to it. The part that I'm talking about right now, where you're going through and you're refining and building your model out of these little pieces based upon all the images you take, and that's called training of the AI, and that can take a while, depending on the power of your machine, and that's where you'll need, again, a powerful machine, or you could be waiting hours for it to be trained. Now, there's going to be a number of software that'll show you they're online, and you'll see how it works is you just upload your images and then it'll get processed. Typically a half an hour to an hour is what I've been seeing. And I wanted to also just point out two things on here. Already the ellipsoid is slowly being replaced, or we're seeing some papers coming out about using triangles instead. And those are included, and I'll show you. We'll get to that here in a second. But I wanted you to recognize that you've seen this brush, or this 2D version. I'm trying to make this as an ellipsoid, but you've seen this in a 2D version, and this is the paintbrush in Photoshop. And you're familiar that if you've stitched something, or you've rendered something, you've done something in the old process, and you've got a seam or an edge or some really visible artifact that you've got to get rid of, you'll find yourself in Photoshop picking a brush and setting it with this nice soft distribution. That is a Gaussian, it's a 2D Gaussian distribution. The reason being is that's how nature works, and you need to blend things together. Up until now, these hard pixels and mesh and the rest of that has made that very difficult. So I like to think of this as we're being able to build the scenes out of, it's a more painted kind of a way. It's a little more comfortable, actually. Makes a little bit more sense to me. So in the next slide, you're going to see, like I said, again, the process of this using an AI, checking against the source images and building out everything. And because I've taken it from around it and it knows where the position of the camera is, as each flat plate, it goes to adjust this Gaussian, and then it moves to the next view and adjust it. It's building a 3D object. So I'm showing you 2D, but you can understand that as it spins, as the AI goes through all of the source images and adjusts each one, knowing what it's done, it's slowly filling out shapes and volumes. And this is kind of trying to show it to you that these are six, those two turned into six. The colors are changing, they're starting to blend together. So maybe this is an arm or something that it's slowly building. But that is the real magic sauce here. That is what is making the Gaussian splat possible, is that we're able to use an AI to rapidly use the feature detection algorithms that we already had, and we're able to manipulate these things and to quickly build them. So you'll go through these iterations, they'll keep multiplying, dividing, stretching these things, and they end up with millions of these. But you'll see here in a second, you end up with a very believable, very realistic looking scene that is not built out of geometry. It starts with the same scanning methods, ends up with the same point cloud, but instead of going down the mesh route and into geometry and back down the traditional pipeline, we're going into really just a bunch of smeared together little things that make it look close enough. You'll see what I mean here in a second. Now, this is moving very fast, and so you've you're seeing a lot of papers, you're seeing a lot of improvements, and that algorithm, that part of the secret sauce, that algorithm where it's checking the image that it's created, that the AI is creating by these using these little pieces versus what you've given it, the ground truth or the source image. There's three main numbers that you'll run across that are being used because the algorithm itself is detecting, like how close am I? And these are the three, and you'll see these again. You don't have to worry about these. These are just being done in there. If you want to get into the research, if you want to see some of the papers, you want to see why triangles are better than the Gaussian, you can click on this link here, and it has a really nice set of all these examples, and you can move the slider back and forth. And you know what? I think I'll do it really quickly just to show you what we're talking about. So these images that you're seeing here, these are all created, right? So these are not the ground truth. They're comparing the Gaussian splatting with this new triangle. And look under, I can't zoom in on it because the controls go out, but if you look underneath the bench, you'll see how the triangles are allowing it to provide a lot more detail. The grass, the long, thin lines, when you try to do that with an ellipsoid, they end up kind of getting all smeared out. And because it's under the table, they're not used, sorry, under the bench, they're not using as many. But that you'll see, you can go through these. This is a very classic image. Oh, that's an important thing. In when you click on, like, see, I clicked on this thing right here, and this is a paper. They'll have the code and go to the GitHub repo. If you don't know GitHub, that's okay. In almost all of these, they'll provide the this is kind of a neat one you can see. They'll provide the data, the images that they've taken that are already processed. So as I said, you're going to have some learning curve to get images right. And you're going to want to produce and play with the software and dig around with it. You're going to be dealing with learning images and learning the software at the same time. So you might want to just grab one of these data set, grab the images from one of these things, and then load those up because those have been processed and those are going to work for you. So let me close this out and go back to this. So again, and I'll put the PDF here at the end. Throughout this, I have all these links, and they're really nice links. There's a lot more to this. I wanted to give you an introduction to this whole thing. But if you want to get into it, you're going to have to do some reading and learning, and I've included it for you. Go back to here. Okay, yeah, actually, that was it. Okay, so we're going to start looking at some examples, and we'll have plenty of time for it. So we'll have lots of time. That's good. I wanted to kind of get through it quickly because you're just going to have to just download these things and start playing with them. So I'm going to go through a couple of these. I've got them divided out into applications. So you'll find them on a mobile app. They might have a desktop version of them. I would start with those: Scaniverse, Reality Scan, Polycam. Some have trials, some are free, but you can just get out with a camera and be taking pictures and stuff. So let me start with Scaniverse, right? So I'll just kind of let it sit here for a second. You guys can still hear me, right?
Yep, we
Oh,
hear you.
okay, good. I was getting sometimes that bad connection. But so you're seeing here, this is this is why I would recommend starting with, if you're new to starting with the photo apps. They're doing all the heavy lifting for you, and you can focus on the technique of how to do objects. And that's the two different ways to do an object or to do the interior of a space, because the exterior of a house is also an object. I haven't been playing with a drone, but it seems like the drones work really well, and they do some pretty cool stuff. And you can do mixtures of them also. You can do, low with a regular phone, and then I've seen ones where they'll just grab the top of the building with a drone. So that's Scaniverse. So I would definitely recommend this one. It does, I'm not able to use this one on my phone. It does have some stringent requirements. You got to have a pretty decent phone or an iPad to use this one, but that's okay. I don't have it. The other one, Reality Scan's a fun one. This one I like. It has, and this isn't necessarily a Gaussian spot. This is a very powerful tool for just doing scanning. So for photogrammetry, processing things. And it also has an app on here that you can, yeah, if you click on the mobile, it'll pull it up. Right. So yeah, I'll go ahead and play it and you can just see, you're able to see the things, but I don't want to spend too much time on here just so you understand what we're talking about here. So this,
With Reality Scan, you can create photorealistic 3D models of real-world objects using your smartphone's camera. Here's how it works. Start taking photos of your subject.
okay.
The photos appear in the camera view so you can see where you've been. Keep each new photo close to the last one, working your way around your subject from all angles. While you work, your images are continuously uploaded to the cloud for processing, and results are sent back to you. Images that fit together turn green. Problem images turn red. Reality Scan will indicate to you how to fix them. You'll start to see quality markers appear as colored dots on top of your subject.
Okay. So that's why the apps are kind of nice. And that one's really nice in that it kind of is teaching you where you need to think. So I've been playing around with that one. I'll show you Polycam now. And Polycam has a license for it, 7-day free trial. And I'm going to show you mistakes. So, but I'll explain why these didn't work out. So this is over at Harper's Ferry. I'm just trying to take a thing of a monument, and so I'm now in their viewer. So this is a Gaussian splat viewer. There's each of the different applications will have a different viewer. We'll show you some of the features in these. Almost all of these are using the game controls, the WASD, right? So I can press W and move in and back up because I'm in an actual VR space. I noticed some of them don't actually do it. Like this one doesn't have the Q and E, which should be up and down. So that's kind of bothers me. You have to click two fingers to pan and move things around. But let me show you what the mistake I'd made on this one is I'm using okay, so there's a number of mistakes on this one. I'm using a D850 Nikon. I've got a Tamron 15 to 30 millimeter lens. I'm at 30 millimeters. I've done some testing with 24 will work. I start to go below 24 and I get problems. So that kind of is the limit of what I can do with a full frame. You can use 360 cameras, but the process is a little bit different and there aren't any well, there's some applications now, but the 360, when you use video, you have problems with distortion, rolling shutter, other types of things like that. What you're seeing here is so when I was taking the photographs straight on, it's okay, right? But because I didn't have enough light, and I believe I had pumped the ISO up to almost 1600, so I'm starting to get noise. I went beyond that, I had problems. But you'll see that when I take the shots from the side, I don't have all of the monument face in focus. And unlike PT GUI or some of other programs where it knows the difference between it'll actually stitch more of the sharp, right? So there's some, or I could go in and into a Photoshop, I could export out that panorama in the layers and the part that's a little bit blurry I could recover from. That does not appear to be possible in this stuff. Culling your images, getting rid of blurs or other things kind of seems to be kind of critical. And that's why I've ended up with the blurred images that you can see, right? As I'm taking a photo here and it's in focus, it's starting to lose focus, is ending up, it wrecked it. The other mistake that I made is if I go to the top, I didn't take enough information, enough photographs at the top of the monument. I just kind of like, and I think I either didn't take enough or I moved too fast from the face to the top, and so it wasn't able to connect. So I lost a lot of the data on that, and that's why I ended up with the top not looking correctly. So this is why I'm recommending the apps will make it look like, yeah, just go out, we're good to go. You're gonna find out that the technique you're gonna have to practice. For example, I'm used to inside, and unless it is, really well lit, that I'm not going to be hand holding that camera. I'm going to have it on a tripod. If I want everything in focus, right? I got to have the entire room in focus. I shouldn't really be going above an ISO of around 800 for most cameras. I'm probably looking at maybe f8 to f12. If I go beyond f12, I'm going to start getting, I'm not going to really get the best quality out of that lens. That's a slow shutter speed, and you're going to be sitting on a tripod in a normal room, doing, normal size room, living room, whatever. I could get away with maybe 3 panoramas, right? And that's from a real estate point of view, presenting that room and what it looks like. 3 panoramas, I'm in and out. To do this with the Gaussian, I believe I'm into hundreds of images, and those hundreds of images aren't going to be taken handheld. I'm going to have them on a tripod, and I've got to take them at near floor level, kind of looking down a little bit, up, up. If I've got any furniture in the room, I got to be going all around it and stuff. So just, I'm not poo-pooing this too much. I'm just saying that you've got to understand there's a lot of work to this. So play with it, get used to it. Kind of reminds me when I first started virtual reality, that I'd go out and I would take things, and man, it just did not look like what I'll show you here in a second. They're really nice stuff. So I'm going to go ahead and close that out, and we'll go back to this. So let me show you now some of the nice things. Post shots, an important one. Splatical is one. I left the commas here on the end because this isn't all of them. Do some more research, and I know they're just like popping up. So at the end of this in the chat, definitely put things in. Let me know if you had. So here's one I think is kind of cool. Godzilla Pro, and I want to show you. This is what we'll start to cover in the second part of this. We'll start to get into, and I'm just going to show you 2 examples that they have. Sometimes I have trouble finding it. Pro. Get yourself on the waiting list. I think I've talked about that before. Always try to do beta testing and such. Where was their examples at? Gosh darn it. Well, I'm going to go ahead and just play there. This is a video. This is a preview of their beta version. And I'm going to point out, I'll let it play, but I want to point out some of the features that you're going to see here and some of the differences between what this technology can do versus what traditional photography would be able to do. Even though we're not going down the mesh pipeline, right, which puts you into the Unity, Unreal Engine world and stuff, we're ending up with, well, we don't go that route because it's too difficult, right? It's not our forte, and all the modeling and geometry, all that stuff. This method allows me to end up with a model where I can't actually go that route. And so what you're going to see here is the ability to remove objects in the environment. It's a truly immersive. So they're able to remove objects, they can scale them, they can do some pretty cool stuff. And you'll see hot spots. You're able to add that. So that'll be the second part that we'll get into, but I want to give you kind of a preview of it here at the start. So let me put this into full frame, and I'll talk a little bit over it as it goes through. See, so they're in a museum. You see they got a WASD movement capability. Now notice as they rotate or move, though, you do have a shimmer, right? You get some of the reflections will pop and stuff. I'm sure that'll eventually, that will slowly get fixed on, but a very good resolution. You're noticing some blurring though. Some of the things, they're not perfectly in sharp. Here's showing you hotspots. Pretty impressive, right? Because we're dealing not with a 2D area, I'm dealing with a 3D object. My rollovers aren't polygons anymore. They're the actual object. The actual object's interactive. So the ability, you know, so they're highlighting the entire object as well. Now here they're going to show you how they're able to move or select things. And we'll get into what these editing tools are. We didn't cover that at all but you can see the difference between obviously a photograph and now dealing with object. You'll see a lot of work or progress with Gaussian splatting in the construction, facilities management, remediation stuff. Because this is a pretty cool one too, because you have a 3D object, so you're able to annotate it. You have geometry, you're able to play with it, move it around, do things with it. And this is not something that would have ever really been possible for our realm unless you happen to know Unity and do modeling and things like that. So it's pretty impressive. Now, when I look at these, I keep thinking in my mind, this doesn't look as good as photography. You know, they're not. This is moving so fast. I have to believe that they're going to get to the photorealistic quality that it'll match what we're able to do with just, you know, high-end DSLRs. But being able to do that kind of those types of things with something. Let's see. Oh, I believe that for us, the workflow, because I've mentioned using using a handheld phone, taking photos, using my camera, taking photos, handheld, it's so difficult to like move, you know, and take it and to not mess up, especially if you're using like that, you know, the autofocus, time between the autofocus, you start to take 500 shots and you just start to mess some of them up. So I'm seeing that a 360 rig, right? A 360 camera that you're just going to pass through. That's going to be the workflow. I'm almost positive, right? You're going to take an Insta360 or something like that. And you still have to understand how to capture the imagery. But you'll end up with a video that you process. And there's a lot of work being done on fixing the issues with using a 360 video, the quality, being the rolling shutter, things aren't in focus, things like that. But those are very high-end cameras, right? Those 360 rigs. So here's a paper, and I'm going to just show you if you're not comfortable with GitHub, which I completely understand, slowly spend time. There's some really wonderful tutorials on it. Learn how, and this might be a good opportunity because it's not that hard to set up a Windows machine and to understand the command line, to download this code and to start to do some really good tutorials on it. But you get in here and you'll see even if you don't want to do they always have papers in here. They're explaining what they're doing. This is one where they've taken that original paper that I have in here, Gaussian Splatting, and they're now figuring out how to use 360 video. And in this case, they're flying a drone around, and it's pretty cool. And again, you look at the quality and you go, man, that's not what I've seen out of Aeropano or something. We'll get there. We'll get there. It's just new technology. So anyway, so you can go down through here, and the reason that it's good to look at these GitHub repos, even if you're not familiar with it, is they have all kinds of extra information in here. They'll give you links to other people. They're called forks. So if they've put this up here, somebody else has taken it, they've created a fork of it, and then now they're doing something with it. And the reason to do these, to look at these GitHubs, even if you don't understand or you're not comfortable with them, is that the code that's being developed will be seen as a GitHub. It'll appear as a GitHub repo, some open source code that you can use. It'll be picked up. Somebody will slap an interface on the top of it. And that's what that's what the Scaniverse, that's what these other ones are, is these GitHub things packaged. And so it kind of helps you. You can do a lot more. You don't have to wait necessarily for it, or you can start to do things yourself. Let's see, this one is the original paper. This is the one that starts it all. This one is worth downloading the PDF and handing it to ChatGPT and just saying, explain this to me. And it's pretty cool. I wish I had this back when I was in college. It's pretty impressive how you can do this. Now, I had said there's two paths. Most of us, this is a new thing. I mean, pretty much everybody, this is new. And you have two paths where one is playing with the software. How do you stitch them? I mean, how do you construct the Gaussian splat out of the images, right? That's one path to go down. And if you're learning these, you want to be playing with or using good images. The other is learning how to take good images. You'll see here on these GitHub repos, again, even if you don't know how to use them, you'll see all the assets in here. So you'll see videos, you'll see imagery. They'll have these photos. That's why you're seeing that same bike against a bench. And then there's the like coffee table looking thing outside. I think it's in this paper somewhere lower, but that's because they're all using the same images to compare the models against each other rather than trying to introduce new images. So Gaussian Pro, let's go to Splatica has some neat stuff. And again, this isn't all of them. So this is one that is doing the 360 video. I did not try this yet. So I have an old, but I'll pull one of these up and show you. I'm going to stop here for a second and tell you that. So that underlying paper that has introduced this new technique of producing them. We're now seeing we're seeing interfaces built on top of it. And I'm going to show you, I think this one's really impressive. So they've pulled up, this is a viewer, this is a Gaussian splat viewer, and they've been good about, they've got the full WASD, right? So they've got the Q and E. I'm going Q to go up, E to go down, W I'm pulling through the space. I was disappointed though that, true gaming is to have the arrows as your rotation, right? So you're using your four fingers to do your rotation, and on the other upper left of the keyboard is the WASD. So a competent gamer using a keyboard will be able to move through the space and rotate. And unfortunately, they've got what should be the rotation arrows. They have them as the panning, which is a duplicate. And so this is W, this is the forward arrow. That's wrong. It should be a rotation. Because I don't want to have to click on the image and rotate it. I got to take my hand off the keyboard. So this whole interface design, I think is kind of exciting in that really one of the best qualities of a virtual tour or a story or an immersive story is the lack of friction, how easy it is for the person to move around it. And this going to 6 degrees of freedom where I can, move around the shape. No more hot spots on the floor, right? I don't have any little dots all over the place. I don't have to. I just move over to that spot. I like the fact that they've got a quality setting in the upper right here, right? I can go and drop it. And again, I know you're looking at this and like, man, it doesn't look anywhere near, photorealistic or what we can do. But this is, the technology. They have views where you can save views and do things. Trying to think, there was another one that had, let me close that out and let's go to some other examples. I wasn't even on the example page yet, sorry. So those are some applications, the GitHub repos, right? This page is your tools. The next one is, I'm kind of summarizing. We're getting close to the 50-minute mark, so I'll kind of summarize here. Like I said, the real technique that you need to work on is the method of photography. It's different and kind of opposite to what we do in virtual reality. These are two very good documents, PDFs, or I think they're URLs from Unreal Engine and Autodesk, and really they're excellent. Then I've got this one. This is Unreal Engine. Unreal Engine's doing a lot. Now that's because they're, Unity, all of that kind of stuff. We're used to making gaming. Just watch this one. This is a really good video from NVIDIA. It's pretty new. I think it's only like a few weeks or something ago. And they're talking about what they're seeing in the future for this. And NVIDIA is a major mover and shaker in this because the boards that they're creating, these RTX boards, have the ray tracing libraries built into them to allow all of this. So they're promoting it. You're seeing a lot of use and they're promoting it in, like I said, the construction, forensic types of things. They haven't moved into the art or entertainment, storytelling, that type of world yet, but that's standard, right? They're going after the first business applications of it, which are typically industry visualization stuff. So that's a nice one. This is the paper on the triangle. These are two YouTube really good ones. I really enjoyed these two. And just click on one of these and oh, this is his. You go to his YouTube channel. He's got a nice website, but you go to his YouTube channel and here's all the videos. And he's tons of them put out and he's putting them out at a fairly regular basis too. So these are good ones to watch. The other one as well is really good. So this is your resources page. Take a look at that and that should get you going. And then last one, let's look at some more. Now these are from board members. This is from our board member, Daniel, using Luma AI, which I can't tell whether it's available or not, or it's buried onto the website or what the deal is with that. But Luma AI is a pretty cool one. And I'll click on it and it's, so I mean, it's a really, you can see the artistic side of this, right? So this would be an object, capture up close on a plant. I have the same, the ability to zoom in on it. It had a nice, play motion. Now I'm back into where I'm manually controlling it. But that's pretty impressive. You couldn't easily do that with mesh. And also now look, you can kind of see if I zoom out, it looks, real, right? As I zoom in, oh, here we go. There you go. You're starting to see these ellipsoids, and the fact that most of the ellipsoids you're seeing are stretched out into long, thin shards is why the triangles are probably going to be a better method. Is nature is full of lines, and you need an object. Maybe it's a blend. Maybe it'll be a blend of the two objects. Don't know. But this is a nice interface for Luma. Luma AI, kind of like this is again their viewer where they have, they've put features, their own type of interface. So that will, if you're building when we build virtual tours and tell stories out of these, I don't know, will KRPano and all of the 3D Vista, will all of these things have the capabilities built in? Will you have to be in a Unity environment and have to learn that? I don't know. That'd be something we can talk about in part 2 here. We can talk to some of the vendors and see where they're at in adopting these models. But let's victory column. Oh, yeah, Arrival Space is kind of a cool one as well. Take a look at that. It pulls up an immersive space, and so you can move around it, and it's kind of a neat because you got to start thinking about if you can build a truly immersive environment, right? Full 6 degree, whatever. I'll click to start it. Right. So again, kind of the importance of these will be the interface. We'll quickly get the process of building the same, like we build a virtual, we create a panorama. That's not the interesting part of this. The interesting part of it is how do you link them all together, the interface you put onto it. And in this one, you can walk. Right. I think, yeah, see this one they did, I'm using the arrows so the rotation is done correctly. So a gamer I can walk and rotate at the same time without having to move my hands.
Hey,
So,
Lauren, would it be appropriate to ask you a few of the questions from the
yeah,
chat
yeah.
before we get to 11? Okay, so we had somebody ask just now what 3D formats can be published. Can you talk about the formats and the type of file that you get from a Gaussian?
Good point. I could go check, but pretty much so all of them, the Gaussian is usually a PLY, and that is the one that includes all of the extra, view dependent information. But all of the programs allow you to export that out to a standard geometry. So you can take the model and move it into Blender or Unity and start to do things with it. And I still think that we're having a hybrid approach to it where commercial use of this, they're using it to create the model, but they're stripping out all of the information, you know, all that radiance field stuff, and then they're bringing it back in with ray tracing. So they're using the Gaussian splatting to easily get the model or environmental stuff, but then they're moving back into their traditional workflow.
Okay, and then we had,
I'm going to stop the sharing here.
oh, sorry.
Go ahead.
Joel has had his hand up for a while, so why don't we give him a chance to ask?
Oh, okay, I can't see those. Sorry about that.
All right,
Yeah,
all
go
right.
ahead and bring the board back too if you want. I'll stop sharing. What do we got next?
Well, I'm trying to,
There's a lot of questions here, isn't there? Sorry, I wasn't paying attention to them.
Maybe if Joel can post the question, then we can read it, might be easier.
or Joel, just turn on your microphone and then you can ask.
Okay, while we wait for that, somebody asked capturing 360 photos, then you're using particularly KR Pano and Blender with a special add-on in order to recreate the 3D location. What about a workflow with that? I'm not familiar with KR Pano, but is there?
Yeah, Klaus has said a couple times that he is on it and we'll have it in a couple months ago. He said the next point release. One time he said 0.4, and that is the current one. So he has said the next one with Klaus, brilliant, absolutely brilliant guy, but he's on Klaus time. So very soon can mean anything from tomorrow to several months from now. But he will give the ability at some point to import the PLY file into the depth mapped space that you can explore in KR Panel. And then you'll have all the tools that you have available there.
Yeah, I suspect that like with EverPano or the is it PanoCam adder that you'll do those in creating that, you know, that the tours that we've seen on KR Pano, you're ending up with an STL file like a model. And so I'm curious, is that possible that you can use this to create the STL model and then bring it in? So I was going to play around with that and see if we might have the ability to bring these in, but not as they wouldn't be brought in as a Gaussian splat though. They'd be brought in as a model created through Gaussian splats.
One thing I want to mention with Arrival Space, and you started looking at what was it? Schindler 3D.
Yeah.
Anyway, what impressed me there was how they've integrated collision avoidance. So in other words, you can go up to a wall and not walk through it. Whereas most of the viewers, you walk right through a wall. You can walk up a hill and walk up steps, which, you know, that's again, that sort of game-like feel that, or game, yeah, being in a real game that you don't get in a lot of these other viewers.
Yeah, I'm going down through, can you do, I'm going to go through the questions.
So
Oh,
yeah,
go ahead.
Murat asked, can you, this is, it's an obvious yes, but I would thought it would be interesting to talk about the methodology rather than just a room. Can you do the inside of an object like a car or aircraft?
I believe yes. I've seen ones. You're back to that same thing though, and you're filming back, right? So you're instead of the way we would do it in the center of the room, filming outward. If you're inside of a room, you're filming towards the opposite wall, so to speak. But I've seen some nice examples of them up close stuff, and some of the objects like we just saw that the I forget what the flower is, but that picture of the flower, you can get very, very good detail. So I haven't done one yet, but I think the issue is going to be that you really have to have the image all in focus and you have to move the camera around. So I think I'm going to quickly focus on trying to figure out how the 360 rigs work out because I'm already a couple of weeks I've been playing with this. It's using a DSLR is kind of it's overkill and the process just isn't, you know, I guess maybe if I was stabilizing the camera, but even if the camera's stabilized, you've got it, you know, it's stabilized, but you got to stop. and it's
One of the nice things about that Pixel Reconstruct had, where he's using the new NVIDIA software.
yeah,
And in his case, he's just using a fisheye lens. But I've seen with Ali, where he has used 360 video camera, the X5, and just walked around and created really great models with that.
yeah, that's definitely going to be the workflow. And I have that. Sorry, Stephanie, I stepped on there. I have that as in the resource page, so that's a GitHub repo. And again, you don't have to know GitHub, but go to that and that's you might be able to use it.
Um, real quick, they wanted to know, where's the PDF going to be available? Is it going to be posted in
yeah,
the chat? Okay,
yeah.
thank
Thank you, thank you. We weren't going to get it because I was going to forget.
you.
But yeah, here's the PDF. I'm going to click. It'll go to everyone.
Awesome. And then also, what is the best open source viewer that you'd recommend for displaying Gaussian splats?
I really liked the Luma AI, but that used to be Luma AIs. They do all kinds of stuff, and it seems like they've shifted over to the gen video, right? Generative video stuff. So I don't think you can actually access it anymore. But Luma AI was really nice. Scaniverse is pretty good too. It's just most of the viewers that are going to be on a mobile application are pretty crude. There's not really too much to it.
Lauren, there is one that is free for everyone, and you can upload your Gaussian. That is called Play Canvas. It's web-based.
Okay. Yeah, definitely it's moving fast. Definitely play with the free ones. I felt that the Polycam is a 7-day free trial, and then it's something like, $20 a month if you pay for the whole year. I don't think I've had enough. I haven't had much luck with Polycam at the moment. So I think I would stay with Scaniverse or you just said stay with a free one until you kind of get yourself up. Do people get the
Lauren,
PDF?
they didn't get the PDF. You need to swap to everyone. I think that it was just hosts and panelists.
Yes, it was just host the panelists.
I thought I did it to everyone. Oh, okay. I did it and then I sent here's it. Okay, so that should be to everybody now?
Yep.
Okay,
Yes.
cool.
And then for capturing, do you have better results taking oblique shots and panning or taking straight on shots while panning?
Straight on shots while panning, like you're seeing here, like if you're doing a wall, yeah, you want to keep the rotation to a minimum because it's that parallax that is causing the distortion that they're picking up and detecting geometry. So, move, move, move. I don't know. I haven't really gotten a good feel for the size of the object, how many photos. I think I'm taking way too many right now, and I'm ending up throwing, blurry stuff in there. And I think that's how I'm messing up at the moment. Just like we would have long discussions about what's the minimum number of shots to take a room, like a fisheye. Oh, I can do it in 4 shots, or now we're to the point where I got 2 fisheye lenses that can do it in 2. I think it'll be kind of this, you kind of want to test that out yourself and to figure out how many, for an object that's a foot tall, how many shots. That's the kind of experimenting, how far away from it. They say it should fill up 60% of the frame, right? So, if I'm shooting an object, it should be, like that. But how many every 5 degrees around it? How many bands? So I think that you'll just experience on that. Somebody gave us Luma. Thank you. Yeah, Luma's a fun one. I enjoyed Luma. I just couldn't find it. All right. What other questions we got? We're kind of ending. We can end early and send everybody out so they can start playing with it.
What about viewing in VR? Polycam has instant AR mode, but have you viewed your content in VR?
I have not viewed stuff in VR yet. I got a Quest 2 set that one of my board members sold me. And so I'm going to throw that on here later and play around with that and see what it's like to move around in the space. There's not a PDF link. I'm actually just posting it in the chat here. So I think you have to download it. Okay, so people can't see it for some reason.
Yeah, it went to everybody.
Dun, 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 dun. Here, I'm gonna. Just in case you don't get it, that's my email. So just send me an email and I'll get it to you. Let's see. Any other questions?
Okay.
I was
Oh,
going to read that this one's kind of general. It's how to apply this for clients so it can be usable in marketing.
I think right now, probably the one that makes most sense, at least to me, is the object ones. Those are coming out really nicely. There's not a great deal of work. I'm seeing that the immersive ones inside of a space, I'm going to have to do a lot more work to end up with something that I can already do with, just photography, a panorama. But I don't have, I'm thinking like in a museum, a case or a product, a store where I have an object or something and I want them to pull up the object. Right now, I have really like Object 2 VR or things like that. I have the ability to just take pictures of it and move it around and rotate it, really play kind of a movie of it. But with this, I can capture with my phone, I can capture a pretty accurate model. And that model has all of the details, all the texture, lighting. I've seen nice, you'll see them also when you go out there, you'll see a lot of objects. I think those are definitely doable. And in a virtual tour, you could, that's what I'm going to try to do first, is I have a number of virtual tours for clients. We have objects, planes, things like that. And I'm looking at going back, capturing a couple of the cool objects, and then importing them right as a pop-up viewer. So that it's just going to be in HTML. I don't have to mess around with getting it into KR Panel. Because as we said, I think it's going to be a while for a little bit. But yeah, I'm just watching the chat that somebody just said that Shopify would be an impressive way. Because right now, if you want to do product demos and have it look nice with all the lighting and stuff, you're getting a light table or shadow box or whatever, and you're spinning it around and stuff. And you'll see when you use the apps that have the AR on them, where those are really nice because you're like, yeah, somebody just said here, you're able to do that Matterport, that ability to move around, and they're pulling a mesh over the object and telling you, no, I need more shots here or there. I'm finding when I do it just by hand and I go out and I try to move around the object, not experienced enough, I guess, yet, but I'm missing out. I'm not getting that right a number of images. So that's what I'm going to pray with. But and someone's talking about we're definitely going to cover what they're calling 4GS or 4DGS, and the fourth dimension is time. So it's just a fancy way of saying a Gaussian splat movie. But obviously, you can do it with single frame. You can do it with videos as well. And yeah, I've seen some. They're pretty impressive to be able to. And I'm wondering, like, does this compete with volumetric video? Where that was, and they were spending so much efforts to create these immersive video stages and, giant arrays of cameras around them and stuff. I don't know. Yeah, and then somebody's writing about Polycam and the drones. I have seen some really nice stuff from drones. I don't have a drone, but I wish I did after seeing some of them. It's pretty cool stuff flying there. The Pixel Construct has some really nice runs where he's flown around a castle, and it's pretty cool to see.
There's a few questions kind of asking over again about Gaussian splat with video. So if you could just kind of re-explain that process. I think you were talking about it within 360 capture, but someone asked also, would a video quality from a DSLR be more beneficial as well?
I was going to try that. That's a good question, right? The beauty of a 360 camera is the two fisheye lenses, right? So when I meant a 360 rig, like an Insta360 camera and things. My guess is because so many people have those rigs, and if you can get past the rolling shutter or the other types of issues, that's going to be the best capture device. You don't seem to need anything higher than like 4K imagery. So a DSLR, I'm taking 35 meg pictures at what? Like 8,000 on the long edge. I usually I extract those out to about 4K, so 3840 on the long edge. And I'm using Bridge to do those. Also play around when you're doing these. There's some techniques where they'll take the image and you'll drop all the highlights out, right? You'll take the highlight slider all the way down, and you'll take the shadows, run it all the way up. And that will remove all of the lighting variances and stuff. And sometimes you end up, it appears a better model. So if you're wanting to use this to create an object, pay attention to some of that image prepping before you send it into the processing. There's some tutorials that I've included. Pixel Construct has ones on there where you don't want to just take your images. It's opposite the way we do it, right? You have all of your images, you created the panorama, and then you want to highlight it and kind of bump up the dynamic range on it. And in these, for processing, you want to drop that dynamic range down so you don't end up with the light variances or gradients being confused as geometry.
Joe, Oberhauser asked about if you applied a QTVR framework, would it work better? And that would be the cubic format. And let's see, Ollie did a thing about this where he tried doing the cubic versus an equirectangular of the 360 video, and he found that the cubic ran into problems because of how things intersect. So that he found it worked much better just to import the equirectangular video rather than the cubic faces.
Yes.
Laura, if you want to, you can knock off the share screen and just open up the gallery. So, and any board member who wants to be part of this can turn on their camera as well.
I think we got all the questions. Somebody's mentioning the iframe. Definitely, if you're building virtual tours, immersive stuff right now, and HTML environment and things, the first way you're going to use this is popping something up in an iframe, an object, or maybe the corner of a room, right? I was thinking about kind of that, where I have an exhibit. It's in a museum, and it's a pretty bare room, except for one corner has all of this intricate, like a curio cabinet, right, with all these little features on it, and you can't, it's like this flat thing in the panorama. And I'm thinking of doing just that corner in a really high definition and having that as the pop-up where they click on it and they can now explore that corner. And I think it might work because I have a really high photorealistic quality image, right? So they already know that they're in this really nice, and then they're going to pop up something that they're able to interact with and move around it in a kind of a gaming way. And I think it's going to be okay to accept the quality drop because of the ability to go and explore all the little items. So that's going to be my first commercial, is for the client. We're in the process of building this virtual tour and they're all fine with it. And we have just this one section, and I'm going to try to create, and then just pop it up and see what happens, see if they like it. And maybe I can sell them on that, right? You're gonna have to introduce your clients to this new technology, and probably not as an abrupt, hey, guess what? Let's not do that anymore. I mean, I've thrown it all away. We're going to do it completely new now. And clients usually don't like that, right? But so I'll sell it as an add-on, charge them an extra $500.
Yeah, there was a lot of questions that I think are going to be answered in session 2. So definitely want to let everyone know this is a 2-part series, and we're going to address a lot of those things.
That'll be the next one, right?
Things. Yeah, someone's asking about the proprietary. It's moving really fast. And it's impressive how fast. That's why I'm saying with pretty good confidence that I believe this is how we'll be doing these types of immersive graphics at some point in the future. The holdup will be, as it is right now, what do you do with them? The capturing and the producing the thing is one aspect of it, right? It's one thing to make a panorama, but what do you do with it? Adding music and this, like, moving people around the space, and it's going to be definitely a little more difficult, right? It's a lot more power, but instead of, you know, forward and backward through thumbnails or moving from one spot to the next, now you don't have spots, you just have one thing. So how do, rather than, that's very, very different. Like I have, say I have a museum and I want the person to go through the museum. I have 50 panoramas that dump, 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 go in order. Now all of a sudden I've just created the whole museum and they can go anywhere. How do I make sure they go anywhere, right? And it's in video, because in video games, that open exploration or free world by itself doesn't work. You need what they call head on rails is the one. We have enough gaming theory and understanding that we know human nature likes that mix. They like to be unconstrained, right? To move around, to explore all the hallways, but they don't like to get lost. And like, what was I supposed? I want to kill the big boss now. Where am I at? I'm lost. And you like to be able to have some guidance. So, I don't know, it's a fascinating technology. I'm trying to still wrap my head around. And for me, I think of it as we're painting in like these little Photoshop brushes. We're able to smear things together when in fact we couldn't do that before. Oh, yes, 3D from South. There's some really cool the ability, because we're not loading up all this geometry, and the geometry has all of these expensive calculations, you know, like the lighting and all this texturing, you can load up whole cities. And the one NVIDIA one resource I showed you, it has a really cool example where they're in Google Street View or Google Earth, right? So not the Google, but the actual Google Earth. And they're looking at some city, and they've taken a section of the city and turned it into a Gaussian splat. And they're in Google Earth moving around, but then they dive into the city and they're moving around. And you can see the Gaussian splatting is actually picking up the telephone wires, which is pretty unusual. You can actually, you know, see the wires going between buildings. Oh, looks like somebody's put one up. Thank you. Yeah, you'll see a lot of good work in this in what they call GIS, Geographic Information Services, because of the ability to take drone videos and just boom, you know, here's all your geometry. Pretty impressive. Also some very cool examples with construction sites. There's one, the NVIDIA one also will show you over a period of time, and they're building the floors of a skyscraper. And all they're doing is they're just coming out and they just run a drone around. Like a company comes out, you know, once a month or whatever, just flies their drone around, and they're just adding these models on top of each other, and you're able to move through them. It's pretty impressive. Da-da-da. Okay, yeah, so the arrival space, yeah, that has the AI guide. That'll be a cool, right? The AI NPC, indoor virtual tours. And then somebody else is, I'll look at all the, thank you for all the examples. I'll take a look at them. I think that's kind of it, unless there's any other questions. Go out and play. Build some stuff so that when we do the part 2, you'll understand what we're talking about. Like, what does it mean to clean up a model? What are floaters? You know, because the models that you're looking at in the samples, those aren't mostly coming right out of the camera. You end up with this, because if you're moving around an object, you're picking up things all over the room. So you end up with this mess, and you got to trim it down and start to do things. So, but that's what we're going to get into in the next. And we might even have some of the vendors trying to get some of the folks from Godzilla and some of the other, you know, I guess I'd call them the computer science folks that are pushing this, right? Because they're looking at just the algorithms and they're interested in the computer science of it. We're the ones that are going to be their end users, right? They're building, they don't know what they're building our products for us for. And that's why a conversation with would be interesting. For example, they should be using the WASD gaming controls correctly. And, you know, I need to talk, we talked to the vendors and stuff, but we'll be able to guide or kind of shape these tools, both KR Pano, 3D Vista, Pano 2 VR. If this is an up and coming hot item, they'll have to figure out how to turn their builders and the virtual tour editors into handling these models or working in this realm.
One thing I'll point out is that this stuff is way cool. Absolutely. It also is very resource and time intensive.
Yeah.
And it'll get better as we move on, but it's never going to be at the level of what creating a virtual tour today will be. So virtual tours will still exist as they are now for purposes where they fulfill the need. And then there'll be these Gaussian splats, these sixed off environments that will fill different needs.
Yeah, we're about 50 years into the traditional graphics, to get to where we're at right now. We're not going to shift overnight because a lot of it, the entire process, color grading, rigging, there's no rigging or motion capture, no support of that stuff for you right now. So if you're in Maya or Houdini or something and you're needing to move things around and animate them, you don't have that inside any of these controls yet. They'll get there, but it's going to be a long time, because what you're looking at on these GitHub and these other ones is just the algorithms, the libraries for producing these graphics. These aren't the actual interfaces, or how do you edit them or put things in them, or how do I move around inside of them. They're just stripped down viewers. Much like when GoPro first came out, when they bought Kohler and they had the 360, I forget what it's called, but that was like the best viewer for viewing 360 video. And it was just a standalone. That's what these are right now, these Gaussian splat viewers that you'll see. They're just strict viewers. Yeah, the Gaussian splats are their ability to capture an environment in its as-built condition. That's a really important as-built condition is very powerful. Like Scott said, it's a little bit intensive right now, and that's why you need to go out and practice and play with it. You'll understand. Like, don't sell all your tripods and panorama heads just yet. And you'll see why. But like I said, I'm going to try to incorporate him into my work. I'm going to try to bring the Gaussian splats into my things, but we're at the end.
Okay. Thank you everyone for attending, and thank you, Lauren, for putting this together. This, if you guys don't know, this was a lot of effort on Lauren's part, and it is very much appreciated. You do have a talent for presenting.
Thank you. I appreciate that. Yeah, it's a fun one.
Yeah. And again, for everybody, this is the sort of thing that we do, and I think we all agree that this is really kind of valuable, being able to spend some serious time exploring a subject, having interaction back and forth. The live events are cool, open to everybody, but there's a wealth of stuff that is on our website recorded that's available for paid members. And a professional membership at this point is just $50. It's dirt cheap. So consider joining if you aren't already. And we look forward to seeing you again.
Next webinar, what's the next one? The 26th?
Yeah, last Saturday.
And it will be part 2?
Part 2.
Okay.
Yep. I'm hoping to get some of the work with Scott and some of the board members, hoping to get some of the vendors in that are, at the forefront of this, the computer science folks, and then also some of the 3D Vista, see what they're planning. We can talk a little bit about the plans. But yeah, it'll be about, hopefully you've gone out and you've got some of these things and you figured out how to do this. This next one will be about how to trim them, edit them, move them around. We'll talk about how to move it into a Unity environment just in case, and how to actually make something out of them.
Exactly. Okay, everybody. Thank you. Thank you very
thank you.
much.